Everyone, and welcome back. Okay, now in this video, this is the first section. Okay, we went through the different sections we should be expecting in the last video. Okay, and this is going to be the first section. Now this first section, we are going to be looking at the big picture, the big concept behind integration. What is integration? Okay, what do we aim to achieve whenever we're integrating? What's the difference between integral and then integration, and how do you go about it? That's what we are going to be looking at in this concept. Now, integration, when you talk about integration is actually a process. It is simply the process of you picking a derivative and then transforming that derivative to get the function that resulted to that. Okay, in differentiation, what you do is you differentiate a function to get a result. The result you get is called the differential or the differential coefficient. That's the result you get. But now you want to reverse this process. Okay, when you're reversing this process, what you do is called integration. So that's the reason most persons, when they want to define integration, they say it is the reverse of differentiation. But in all, integration is simply the process of finding a function whose derivative actually exists. So you already know the derivative, and now you're trying to use the derivative to get the function that results to this derivative. Now, one thing you have to notice is, unlike differentiation that is definite, once you differentiate a function, you always get one precise answer. In integration, it is not like that. Okay, you can integrate a function too many times and then you get different results. Now, this is the reason. When you integrate a function, there is always a constant attached to it. That constant doesn't have a particular answer. It depends on the states of your integral. Okay, so once the state of your integral changes, that constant is also going to change. So what do you actually mean by integrals? Now, since we said integration is a process, what's now the difference between integration and then integral? Because you've heard me mention integral a couple of times. Now, before I go into telling you the what's it called, what integral is, just know that in differentiation, like I explained earlier on, we have these two things. We have this function. This is what we know. We have a function, and then we have this. This is what you call the derivative. You call this the derivative. You call this the differential coefficient. So we are saying the process that takes this function and gives you this result is what you call differentiation. While the process that takes this result, takes this dy dx you have here, as we call usually, and then give you the function back is what you call integration. Okay? So that's what we have in integration. So what we usually do, we assume that we have a function g of x, and I'll let g of x be this derivative we already have. So if g of x represents the derivative, how do we take g of x and integrate g of x? That's integration. So once you integrate g of x, you're going to get a result, f of x, which is this one we have here. You can see that's what the arrow is telling you. It's going to give you f of x. Now it seems like, yes, it's quite straightforward. You pick this one, you integrate it back, you're going to get this. But that's not the case, because after you get this result, there is always a constant attached to it. Always a constant. This constant is always meant to be there, and that constant is referred to as the constant of integration. So usually we make use of c, but that doesn't mean you must use c. You can go ahead and use any other thing you want. You can go ahead and use k, you can use a, you can even decide to use your name, I think so. But that's the truth. You can use anything you want to use. It's mathematics, it's not rigid. Okay, so that's what you call integration, and this is the whole process when it comes to integration, the big picture behind it. Now, what about integrals? What do we call integrals? Now, integrals are simply the result we get from integration. So when you pick a function and then you integrate it, like we said here, when we integrate this function, we are going to get this result. This result we have is what we call integral. So integration is a process, integral is the end result, the final output you get. That's what you call integral. Okay, now there are generally two kinds of integrals. We have what we call the indefinite integral. Now the indefinite integral is when you see something like this. Okay, it's basically they don't have limits. You have just an integral like this. You want to integrate a function, that's called indefinite integral. But we have another one that we call the definite integral. Now for the definite integral, it is still going to look like this, but the extra thing you have there is that you have this men here. These are called the limits. So this is called the upper limit and this is called the lower limit. Okay, now one misconception about this limit is this, especially when you start applying this into different areas. Okay, most persons tend to think that the upper limit should always be greater than the lower limit, but that's not the case. The lower limit can actually be greater than the upper limit. It depends on the concept you're looking at, the situation at hand. Okay, so these are two kinds of integral we have: indefinite integral and then definite integral. Now in the first few examples we are going to take, we are going to focus on indefinite integral. Then we are going to have a section for definite integrals. Okay, so we are saying indefinite integral, we pick this function, we integrate it, we get this as our final result. But what do we do when it comes to definite integral? For definite integral, you still pick this function and then you integrate it to get this result. But instead of you adding that plus c that we had in indefinite integral, you have this pipe symbol. Different authors use different things, but this is what I love using, and this is what you see in most other books. So you have this is called a pipe symbol. So you put this pipe symbol to signify that you want to include the limit where you have the lower limit a and then you have the upper limit b. Now there's something that also goes on after you including this upper and lower limits. You're meant to substitute wherever you see x, you put b rather, the upper limit, minus wherever you see x, you put a. But that we are going to treat in a separate section, so I'm not going to bore you with all of that right now. Okay, and that is all you should be expecting, and that's the big picture when it comes to integration. So in the next section we are going to be looking at some standards. Okay, that's where we start getting our hands dirty, because we are going to be looking at some formulas and see how we can solve questions using those formulas. So take your time and go through this video. You can go through it on and understand every piece of it. If you have anywhere that you're not clear, you can go ahead and ask questions. Okay, and I'll see you guys in the next video. Bye.